Number 4, europium crystallizes in a body-centered cubic lattice. So right away, that's going to tell me, body-centered cubic lattice, that's going to tell me there's 2 atoms of EU per cell. All right. The density gives us a density again. How nice. Calculate, there's our verb. Calculate the what? Edge length in picometers. And then, what is the radius of the atom? Okay. Well, let's work on this. I know that europium has 2 atoms per cell. So I need to get volumes, right? Because if we look again, if we do the... Oh, didn't quite work. There we go. If we duplicate that there and make a nice crystal structure. All right. So body-centered means we got atoms at the corners, right? And there's also one inside. And we go diagonally through. So we'd have an R, an R, an R, and R. There's 4 radii, right? And so the edge equals 4 radii divided by the square root of 3. Okay, that's our little formula. You don't have to memorize that. That's on your sheet. Okay. All right, so what do we do with this? We got to figure out the edge, then we got to figure out the radius. Well, if I know how many atoms are there and I have the density, I can figure out the size of the cube, right? So we're going to start with our 2 atoms of europium, EU. All right. And we know that there are 6.022 times 10 to the 23rd EU atoms in 1 mole. Then we know the molar mass, right? Europium is, I can't see it on my table, 151, I got 151.96. Yeah, 151.96. That's what I got on mine. All right, if you just have 152, go ahead and use it. That's okay too. And then we know that I did that backwards. Sorry about that. Let's try that again. 1 mole on the bottom is 151.96 grams. How about that? That's a lot better. And then we can do our density. 5.26 grams of europium is 1 centimeter cubed. All right, so I have 2 divided by Avogadro's number, 6.022 times 10 to the 23rd, times 151.96 divided by 5.26. So I got 9.59 times 10 to the negative 23rd. Well, I have congruent edges, right? So all the edges are the same size. So the edge is cube root of the volume. So our edge and the volume is 9.59 times 10 to the negative 23rd centimeters cubed. So the edge looks like 4.58 times 10 to the 8th centimeters. All right. But we want picometers. All right. So how do you convert it? Again, some of you guys are really good with the metric system and you can just do it. If that's you, great. If not, let's convert. We know that 1 times 10 to the 2nd centimeters is 1 meter. And 1 meter, there's 1 times 10 to the 12th picometers. All right, and so if I do that, I get basically 458. All right, 458 picometers. So there is my edge length. So the answer, that's number 1. And that's right there. There's number 1. Now, what's the radius? Now we got to do edge equals 4r over square root of 3. Well, what if you multiply both sides by the square root of 3? I would have edge multiplied by the square root of 3 equals 4r. Then you divide by 4. So the edge times square root of 3 divided by 4 equals the radius. So that means the radius would equal our 458 picometers times the square root of 3 divided by 4. If I did that, 458 times square root of 3 divided by 4, I got 198. 198 picometers. All right, so the key to this problem, I think one of the keys, is knowing body center cubic has 2 atoms, right? Because you got one inside the cell in the body, so that's 1 atom. And then you have each corner, and I missed that corner, sorry, my little drawing. You got 1 in each corner, so because you have 1 in each corner, you have 8 corners. 8 times 1/8 is 1, so you have 2 atoms per cell. So you start with the 2 atoms, and those 2 atoms, you can figure out how many moles that is, which is a tiny amount, and then figure out how much that tiny amount weighs, and then find the volume of that tiny amount, which is a tiny volume, as it should be. And then, because it's cubic, you can figure out the volume really easily. And then I convert that volume from centimeters to picometers, right? And then we use our edge formula, edge and radius relationship, to figure out the radius. So that's how we do number 4.